Hello students, in this video we are going to discuss question number 11 to 20 from General Organic Chemistry of Advanced Problems in Organic Chemistry for JEE by MS Chouhan book. In question number 11, the functional group present in cortisone are, so here one molecule is given and we have to find the functional group present in the molecule. So in this position we have alcohol, this is ether, this is ketone, this is another ketone, and this is alkene. So alcohol, ketone, alkene and ether, these four are the functional groups which are present in this molecule. So for question number 11, option B is the correct option. In question number 12, select the acid with the highest Ka value. So highest Ka value indicates the most acidic molecule you have to find. Most acidic molecule you have to find. If we compare the acidic strength, we should go for the conjugate base stability. So we can say that more the stability of the conjugate base, more will be the acidic strength, more will be the Ka value and lesser will be the pKa value. So here we have to compare the Ka value. So if the conjugate base is more stabilized, then the acidic strength will be highest. If we start with the first molecule A, in this case conjugate base is resonance stabilized. Conjugate base is resonance stabilized, but we have one CH3 group present here which can show plus I effect. This plus I effect will destabilize the conjugate base. If we go for the molecule B, the conjugate base will look like this. Here also the conjugate base is resonance stabilized, but due to the presence of two Cl electronegative groups which can show the minus I effect, this Cl2H group can show minus I effect, and this minus I effect can stabilize this conjugate base. In C and D, both we have conjugate base in this position and halogens are present in this position, but as the length of halogen and conjugate base negative charge is 1, 2, 3, 4, 5, 6. It indicates that inductive effect is not effective from this distance, because inductive effect can show the effect maximum to 3 bonds. Here we have 6 bonds, so halogen cannot show the minus I effect in this case, where this alkyl group can show plus I effect which can destabilize the molecule. So in option A, C or D, in all of the cases conjugate base is destabilized by the plus I effect. In only option B, the conjugate base is stabilized with the minus I effect of CCl2H group. Hence it will show the highest Ka value and lowest pKa value. So for question number 12, option B should be the correct one. In question number 13, the most stabilized carbocation among the following is. So all of the carbocations are not resonance stabilized. So we should go for the hyperconjugation. So here we have 1, 2, 3, 4, 5, 6, 7, total 7 alpha hydrogens for hyperconjugation. In this case we have only one alpha hydrogen for hyperconjugation. Here we have 1, 2, 3, 4, 5, that is 5 alpha hydrogen for hyperconjugation. So in the first molecule we have most number of alpha hydrogen which can show 7 hyperconjugative structures. That's why for question number 13, option A should be the correct option. In question number 14, arrange the following increasing order of their K values. Same thing, more the stability of the conjugate base, more will be the acidic strength, more will be the Ka value, lesser will be the pKa value. So here we have to go for the pKa values. So in the molecule X, if we draw the conjugate base structure, here we can have 3 canonical form. This is one canonical form, this is canonical form number 2. We can draw another canonical form like this. So this is canonical form 3. So in X we have 3 canonical forms. Now for second molecule Y, we have CH3C double bond OO minus. This is one canonical form. Again, this resonating structure can be drawn, and it can give another canonical form. So in the Y molecule we have two canonical forms, and in Z we don't have any canonical forms, where this negative charge is unstabilized by the plus I effect of this methyl group. So the conjugate base stability order, if we write down the conjugate base stability order, that is X greater than Y greater than Z, and hence the pK order should be X greater than Y greater than Z. Okay, so for question number 14, option B should be the correct option. In question number 15, which is the major product of the following reaction? Here we have used 1 mole of HCl. So most basic nitrogen will react with 1 mole of HCl. Here we have two nitrogens. This nitrogen is resonance stabilized. Okay, as this nitrogen is resonance stabilized, this is not a localized lone pair. So as we know that more the electron density over nitrogen, more will be the basic strength. We can say that for this nitrogen basic strength is low. Why? Because this lone pair is resonance stabilized, so basicity is less. Whereas this nitrogen is not resonance stabilized or not involved in any resonance, hence it is a localized lone pair, and plus I effect will increase the electron density over this nitrogen. So this nitrogen in the green circle is more basic, that's why it can react with HCl easily. So in this case this nitrogen will react with H plus and will form a NH bond with positive charge over nitrogen. So option B should be the correct option. In question number 16, in the given pair identify most acidic compound between A and B and most basic between C and D. So if we compare this 1 and 2 molecule, in the second molecule we have ortho effect, and as we know that in presence of ortho effect, carboxylic any benzoic acid will increase the acidity. So for the molecule A, second one is more acidic. But in option B, we have again two molecules, but we don't have any ortho effect because we don't have benzoic acid system. In this case, this conjugate base is unstabilized by the plus I effect of the methyl group. Okay, so in the second option, the first one will give the most stabilized conjugate base because there is no plus I effect present. So for A, option 2, for B, option 1 is correct. So our answer up to this point is A2 and B1. Okay. Now as we know that in presence of ortho effect, the basicity of aniline will decrease. So for the third option, molecule 1 will be most basic, and for option D, as methyl group can show plus I effect which can increase the electron density over nitrogen and it will become more basic. So for the option D, second molecule is more basic. So for C we have 1 and for D we have 2, and for question number 16, option B should be the correct option. In question number 17, we have to find several factors steric electronic orbital interaction for this answer. So we can say that if larger groups are present in the same plane, the amine inversion is become difficult, and amine inversion is not possible because of the inversion barrier value. Okay, so in this case, if we place 3 methyls in the same group, it can show higher steric hindrance compared to 2 isopropyl and 1 methyl, because 2 isopropyl will have 1 hydrogen which can be placed such that the steric hindrance can be minimized. So in this case, option A, in the initial molecule we have higher delta G dagger value, that is correct. So in second option we have 2 rings. As we know that if member of the ring is less, inversion of the ring or flipping of the ring is quite difficult. So here we have 3-member ring, here we have 5-member ring, and we can say that in 5-member ring flipping of the ring is become easier, and that's why delta G dagger is less. Here we have 3-membered ring. Flipping of the ring is difficult. That's why delta G Dagger value is higher. In this uh, third molecule, or option C, we have two molecules. Here we have 3 methyl groups, and keeping 3 methyl groups in the same plane is quite difficult. But keeping 3 chlorine in the same plane is much more difficult due to the presence of 3 lone pairs. So here we have lone pair repulsion, which is quite more destabilizing factor. That's why in the second molecule we have higher delta G Dagger value. So A, B, C, all of the options, the delta G Dagger value is placed correctly. So option D should be the correct option. In question number 18, select the hybridization. So this is sp2 carbon, this is sp carbon, this is again sp2 carbon, this is again sp2 carbon. So we have two sp2 carbons, one sp carbon, sorry, this one is sp, two sp2 carbons, sorry, three sp2 carbons, one sp carbon, and we don't have any sp3 carbon in this case. Okay, so for question number 18, option C should be the correct option. Circle represent most basic. Okay, so in the first molecule, this lone pair is involved in aromaticity. That's why this is not present to show the basicity. That's why this one is less basic. Where this lone pair, is present on a sp2 hybridized nitrogen. So this is a localized lone pair and will show more basicity. So the circle is correctly placed. In this case, these two lone pair are resonance stabilized or involved in resonance. That's why the basicity is less, where this is not involved in resonance and basicity will be high. In this case, again, this lone pair is not involved in resonance and the hybridization is sp3. So that's why the minimum S character are not involved in resonance will show the more basicity. So all of these are correct. In question number 20, we have to find the most acidic hydrogen in the circle 1. So in this case, the conjugate base is stabilized by the electronegative CF3 group or minus I effect of the CF3 group. That's why this one is more acidic in nature. If we remove hydrogen from this, the conjugate base will become aromatic in nature. That's why this is acidic hydrogen. And between alcohol and carboxylic acid, obviously carboxylic acid is more acidic because the conjugate base is resonance stabilized. Hence for question number 20, again all of these are correct. Thank you for watching.